Good morning to everybody. Welcome to ARC's webinar, Sensors for the Age of IIoT. My name is Mark and I will be the moderator for today's session. In this webinar, my colleagues Florian, Ebele and Naresh will provide you a market overview, trends and opportunities on smart sensors, real-time location systems and RFID systems used in manufacturing. They will also discuss about the impact of Industrial IoT or Industry 4.0 and analytics on these sensor businesses. And now, without any further delay, I would like to pass over the word to my colleague Florian. Florian, can you hear me?
Yes, thank you, Mark. I can hear you very well, and also a warm welcome from my side here in Munich. Welcome to this webinar of ARC. We have the following agenda today. We have the driving forces behind the rise of smart sensors. We then will discuss smart sensors, real-time location system, and RFID. And then I have the honor also for some closing remarks, and then we actually go into the Q&A session. What are the driving forces behind RFID, real-time location systems, and smart sensors? We years ago started research on that topic, and we actually figured out that a lot of the driving forces are coming directly from the markets and not by tech nerds that want to use some fancy new technology, but they're actually triggered by fundamental changes and movements in the society and also in the consumer market. So on the upper left side, we have a couple of the, let's say, big trends, sometimes referred to as mega trends. This includes the increasing wealth in emerging markets, urbanization also in emerging markets, but as well as in developed economies. We are talking about hyper competition, which also leads to shorter product life cycles. We have political crisis and as well as economic crisis, available technology, that really changed a lot over the last years, and we have the shortage of labor. Now, if you just take, for example, the first one, increasing wages and wealth in emerging markets, and shortage of labor and engineers on the last one, it actually will trigger the share of automation, tasks that have been done by hand in the past by very poorly paid people. They are now done by pick-and-place robots, by Delta robots, by all sorts of machinery. The political crisis, as well as the financial crisis of 2008 and 2009, it actually triggered political initiatives and economic initiatives to recapture parts of the global manufacturing value chain. Industrie 4.0, the German initiatives, is partly comes from the industry, but also from the government. And the goal is to actually get manufacturing jobs. They are more stable than jobs in finance, insurance, and real estate, called FIRE. And the hyper competition and shorter product life cycles, this is triggered by saturated markets. So right now, all markets are saturated. And this triggers the need to fully automated flexible systems. So it's not a good thing for an end user to manufacture the same thing over and over again. It needs to be flexible. And all this here leads basically to the rise of smart sensors in manufacturing. And by the broader term of smart sensors, we also include RFID as well as real-time location systems. Now, just a few more words here from my side before we dive into the technology. In the past, the sensor may just have said something like, it's there, it's not there. Today, it delivers the presence, it delivers the status, it delivers much more information. In the past, we had like the 0 to 20 milliamps and 24 volts, and now the flow meter is actually communicating the flow level. We're now moving to batch size 1, and we are moving from a fixed setup to a very dynamic setup in production. And all this actually builds towards smart equipment, and this smart equipment, this is what drives the smart sensors. So This is the framework, and hopefully we can now dive into the technology. That's why I'm here for, and I'm passing over to my colleague Naresh now. Naresh?
Thank you, Mark and Florian, for such a nice introductions. Good morning, everybody. My name is Naresh, and I'm based in Dresden, Germany, ARC Europe office. I'm going to take you through a summary of our recent research findings on smart sensors and real-time location systems. Before going to discuss about market and industry trends, I would like to give you a brief idea about the scope of this report. And ARC's definition of a smart sensor is a device combined with a sensing unit and a signal processor and has ability to communicate via a digital network or an industrial network. While doing this research, we had plenty of discussions with most of the major suppliers, sensor manufacturers, especially here in Germany, about the definition and scope of the report. And together with sensor manufacturers, we figured out some key features that a sensor should have to be called as a smart sensor. The key features include firstly a sensor which has some sort of built-in intelligence and to self-adjust to the environment, for example, ambient temperature, and can transmit its serial number or build date or such other unique identification data. Secondly, a sensor that can communicate with a host or controller to receive parameters remotely and performs autonomous actions such as communicating more than its measured variables and enables users to track and receive alerts. For example, communicating the device status, as my colleague Florian just mentioned, and diagnostic information like photoelectric sensors, lens is dirty, or a device communication is lost, a sensor is no longer operating, or the target variable is invalid or drifting. In ARC's view, these sensors are at the front line of the Industry 4.0, and with the recent emergence of both Internet of Things and Industrial IoT, the new sensors and associated applications are emerging every day. Increasingly, these sensors are smart and are necessity for addressing the needs of Industry 4.0. As you can see from the slide, the report covers smart sensors of both process sensors, including pressure and temperature transmitters, flow and level sensors, and discrete sensors, including photoelectric, proximity, and position and vibration. And the report doesn't cover encoders, vision sensors, and RFID, as these technologies are covered in other ARC reports and much elaborately. Coming to industry trends, the market size for smart sensors, including both process and discrete sensors, looks around over $6 billion US, and currently the market is dominated by field instrumentation and process industries, as 85% of the total market is covered by process sensors. Looking at the competition, the sensor manufacturers like ABB, Emerson Automation, and Anderson Hauser or Honeywell, Yokogawa from Japan, and Weika from Germany are major suppliers in this segment, mainly focused on pressure and temperature and the flow and level sensors. Though there are around 10 major specialized Europe-based sensor manufacturers, it looks like Emerson holds the major share in the process sensors market as per the research. Looking at the discrete sensors, some discrete sensors started gaining momentum in the discrete industries in the recent years, mainly due to address the needs of Industry 4.0. And the market size for discrete sensors looks over $600 million US. And the discrete sensors, mainly proximity and photoelectric sensors, which are used in a variety of factory automation applications in automotive and machinery, also in food and beverage applications, hold more than 70% of total discrete smart sensors market. Here, looking at the competition, the European sensor companies like Balov, IFM Electronic, and Pepper & Fuchs, SICK, even Kistler, Bommer are the major players in this segment. Also, the IO-Link adoption is a major driver for the growth, and most of the discrete sensor suppliers already have IO-Link sensors in their product portfolios for about three or 4 years. ARC recently conducted a survey on the adoption and usage of smart sensors to gain more insights from users' perspective. According to the survey, most sensors on an average machine are still conventional. However, adoption of smart sensors is growing at a good rate. As per survey, around 25 to 30% of the sensors in today's machines are typically smart, and it is expected that about 50% of all sensors on an average machine will be smart sensors within the near future of about 5 to 7 years. Also, respondents said that smart discrete sensors are addressing some key user challenges, or even OEMs, for reducing maintenance and increasing overall equipment effectiveness or efficiency. And more importantly, the need for digitally capturing or preserving the know-how or knowledge of a rapidly shrinking skilled workforce for the future generation of workforce is a major challenge addressed by these smart sensors. Here in the discrete manufacturing, the promise of driving increased performance and from machines with new sensors and industrial IoT is making smart sensors a necessity. As you can see from the slide, ARC asked survey respondents on how importance of smart versions of various sensors, and most of them said that temperature and pressure sensors are the most critically important sensors, and photoelectric proximity and distance measurement sensors are rated as very important sensors. Also, we try to understand the importance of key features. About 60% of respondents said that receiving an indication that a sensor is no longer operating, a setup has changed, and sensor is no longer communicating to host is rated as a highly critical important feature. And over 57% of respondents said that being able to teach or configure sensors through a controller or a software tools is rated as a second, high level feature for a smart sensor. Moving on to my next topic, which is RTLS. And what is RTLS system? Real-time location systems. Real-time location systems are the systems that provide real-time information about the location of assets, objects, tools, or even people, goods. And the complete system is comprised of tags, beacons that are physically attached to an object or equipment to be tracked. Also, we have receivers and gateways to detect signals and transmit the signals to HMI or external devices. As you can see from the slide, the technologies covered in the report are Bluetooth low energy, and also called as Bluetooth 4.0, and radio frequency identification, ultra-wideband, and Wi-Fi technologies. And the report excludes GPS technology and applications including healthcare, hospitality, people tracking, livestock tracking, and sports, as the report only focuses on indoor RTLS applications for manufacturing and warehouse industries. Looking at the industry trends, the major industries for RTLS market are automotive, aerospace, and defense, and even logistics, warehousing industries. And these three industries hold roughly around 70% of the total market. And looking at the applications market, asset tracking, intralogistics, and the manufacturing operations are the major application markets for RTLS. Just to give you an idea on these application types, and asset tracking mainly includes tracking of mobile equipment, for example, positioning of overhead cranes in a heavy machinery manufacturing industry, and heavy mobile machinery in manufacturing areas, and even underground mining operations. And the intralogistic applications mainly include tracking of pallets, goods, or floor conveyors, or indoor navigation, or sugar trains, and container management, etc. And manufacturing operations include tracking work in progress, as seen as a major user challenge in automotive and aerospace industries for tracking inventory and components, even finished goods, and in-house fleets for material management in manufacturing environments or in a shop floor. Looking at the market trends, currently the RTLS market is in a very good growth pace. As per the research, it is growing about double digits. And the market is undergoing dynamic changes in the market and is expanding with new small-scale suppliers, technology innovators, large automation suppliers, for example, Siemens, and machine builders like Trumpf entering into this market through acquisitions or partnerships with the traditional RTLS suppliers. And the traditional RTLS hardware, tag manufacturers are acquiring are partnering with IoT software platform solution companies and becoming more software and service-oriented companies. Also, RTLS market is getting established with partner ecosystems among manufacturer tags and sensors, wireless network solution providers, for example, Cisco, and IoT software companies specialized on IoT platforms for offering end-to-end interoperable RTLS solutions. To name an example, wireless network solution provider Cisco have established technology partner programs, ecosystems with RFID and Bluetooth tag manufacturing RTLS companies recently. Although the manufacturing sector in general is cautious and investing RTLS solutions, improved collection of accurate location data is playing an important role in improving efficiency of manufacturing processes in these days. And the industrial IoT need for asset tracking and wide availability of RTLS technologies and analytic solutions are the driving factors for this growth. However, it looks like interoperability among various systems is a major concern in the user industries. Looking at the regional trends, North America and Europe are the major markets for RTLS, and North America hosts for quite a few medium and large-sized RTLS suppliers that are offering at least one or more RTLS technologies, including RFID, ultra-wideband, Wi-Fi, and infrared, ultrasonic, and CSS, and so on. And logistics and automotive are the major markets with RFID and Wi-Fi based technologies in North America region. And whereas Europe hosts for more than 10 small and medium-sized application companies specialized mostly on ultra-wideband RTLS solutions and majorly deployed in automotive and aerospace defense industries in the Europe. Asia hosts for small-sized suppliers, mainly offering ultra-wideband and RFID, and seems like Asia is disrupting the market with low-cost solutions from China. And looking at the technology side, ultra-wideband technologies are expected to grow much faster than any other RTLS technologies due to the accuracy of locations.
Good morning, everyone. Once again, my name is Abela Maduakwe, and I will be talking to you about RFID in manufacturing, a key technology in this age of industrial IoT. First, what is RFID? So RFID is well known in industrial applications because of its extensive use for identification in production and supply chain. So this is a technology that comes over from extensive use in supply chain, in warehouse tracking, in tracking goods and services, and in tracking flow of products in the supply chain. So basically, RFID is a technology that enables communication between a transmitter or a transponder and an interrogator. And it's made up of an antenna, a receiver that sends and receives information over different radio frequency signals and ranges, as well as the tag where the information is stored. An RFID system operates in mostly three main frequency ranges, grouped loosely as low frequency, high frequency, and ultra high frequency. And the use of these ranges in production and in tracking process depends heavily on application and on industry segments. For example, low frequency RFID technology is mostly used in semiconductor, as opposed to high frequency and ultra high frequency that is used in other industry applications. In addition, RFID tags, a key part of an RFID technology, can either be passive or active. That is battery power tags that send out information about the location of a product or the information about the status of a machine. RFID technology is very important for Industry 4.0 and Industrial IoT because it collects information on data for goods, on data for products and machine at a relatively cheaper cost compared to other identification technologies. So for example, like compared to RTLS or as my colleague has mentioned previously, other sensors, they're much more expensive than RFID. But as opposed to barcode technology, which is cheaper but not extensively used. The cost-effective nature of RFID technology allows end users to increase flexibility and manage complexity in their manufacturing process. So it enables users to collect data along their production line, which results in a smart factory, as we see in automotive assembly, for example, where RFID is used to track the parts of the different parts that go into the automotive assembly, into the assembly line. It also supports big data goals for end users that wish to further process their machine data on the cloud for further insights. So as you see with applications that look at how a process is done, and applications that allow the application of machine learning or further visualization processes to be done on the data to view over time how a particular flow is being done. Currently, RFID technology is heavily adopted in applications like production and material flow, intralogistic, track and trace, and overall asset management, especially in automotive and machinery manufacturing. So the ability to store information on RFID supports end user goals to make their complex process transparent and efficient. And this is very important because it means that an end user can track their product as it goes along the production line, trace back production anomaly, or access last maintenance information on the machine if it is stored on an RFID tag. Another important part of RFID in the age of Industrial IoT and Industrial 4.0 is connectivity. OPC UA is providing a way for data naming and network nomenclature to be standardized. So this means that end users can use RFID technology to read and transmit information without changing the overall integrity of that information or that data. So, and another main topic for RFID manufacturing is a type of tag technology. So for end users, especially in the automotive sphere, this is very important that tags are durable and can withstand harsh treatment in the production environment. End users are also interested in buying tags that do not fall apart after one use. So tag quality is also an important feature. An interesting feature that has come up in our research for RFID manufacturing is to use tags as sensors. So as sensors that can collect environmental information on temperature and humidity around the production process, around the product, especially if a product is stored in the warehouse or as it moves along the line. And this is a very desirable trait that end users would like to have. So looking at the key industry, RFID technology is basically heavily used in automotive, the semiconductors, electronics, as well as machinery, but mostly for intralogistics and product and material flow. Other important industry that we saw RFID use is in food and bev and pharmaceuticals, where it's used for product batch track and trace, and being able to recall production anomaly, especially if there is a quality problem. The market trends for RFID show that the market will continue to grow. It's a market that is stable but heavily fragmented because there's a lot of suppliers and also a lot of entrants coming in from the logistic or the logistics sphere. But as industries continue to embrace digitalization, this market will continue to grow and would expand. Standardized frequency requirements is also a driver that is pushing RFID manufacturing, especially as various RFID systems can be used together and there is less dependence on legacy products. And this offers end users a bargaining edge in deciding which RFID product they can use and provides a competitive scenario where competition is on price. So the supplier or the manufacturer with the lower price can win over customers. Another interesting trend is the growing market around RFID software and services that allow end users to connect the RFID to the enterprise level software and maintain RFID infrastructure. And an important part of this, as it's connected, is the rise of predictive maintenance and remote support using machine data, which allows, again, end users to be able to predict when next they can issue maintenance on their machine and also support the remote support for maintenance on their various machines. An interesting regional trend, we see that there's the need for flexible manufacturing is boosting RFID use in manufacturing. End users have the opportunity to switch manufacturing batches easily if there is a way to identify, track, and trace different product flows along the production line. However, trade agreements between the various regions is putting a pressure on the RFID market. So as we see with the disagreements between US and Mexico, US and China, as well as EU and the United Kingdom, especially in the automotive industry. So we are seeing this impact heavily in the automotive industry. Overall, there are various suppliers in the RFID market, but most of the suppliers that hold the biggest market share, as you know, are in Europe. And the other part, which is the logistic part, which is not covered in the study, is in the US. Thank you very much. And I would hand over to my colleague Florian to close this discussion.
Well, thank you, Bella. Thank you, Naresh, for this very, very good presentations on the individual products and technologies. Now, I'll make it super quick, so we actually do have a minute or so for the Q&A. The concluding remarks: without identification, there is no batch size 1, there is no Industry 4.0. It won't happen. Without smart sensors, we won't move towards intelligent machines. No way. And without RTLS, there is no efficient flexibility on the factory floor. So all these, again, technologies are fundamental to the new paradigms of production. When you actually search into these technology trends, have a couple of other things in the back of your head. One thing is Ethernet to the device level. Costs come down, so yes, you can also connect low-cost sensors directly to the Ethernet. Think about the ubiquitous computing, having computing power available everywhere at low cost, and actually also artificial intelligence, which is moving down to the controller and to the machine level, and what this could do with smart sensors.
I wish you all a great day, and I hope that you will join our upcoming webinars too. Bye-bye.
Bye, thanks everyone.